solar observatory in space, placing an array of complex telescopes into an environment free of weather conditions and the screening effects of the atmosphere. Telescopes able to observe several solar features concurrently, such as sunspots, appearing as relatively cool, dark areas on the sun's disk. Their magnetic intensities are 10,000 times greater than that of the Earth, and are often associated with energetic activity. The most remarkable fact about sunspots is that their number and area are not constant, but vary in an 11-year cycle. Solar flares, short-lived but vigorous bursts of light, accompanied by intense radiation in the X-ray, ultraviolet, and radio parts of the spectrum. A large flare releases the amount of energy a city of 3 million would use in 50 million years. Flares usually appear in the light areas bordering sunspots. Coronal holes, cooler and more rarefied gases in the sun's corona or outer atmosphere. Solar bright spots, seen in X-ray photos, scattered all over the face of the sun. Prominences, masses of cooler luminous gas condensed out of the corona or shot up out of the solar surface along magnetic lines. Coronal transients, great explosions hurling outward enormous amounts of material, hundreds of thousands of tons in weight, into the sun's outer atmosphere at speeds of up to 2 million kilometers per hour, reshaping magnetic fields and structural features in large parts of the corona. Thus, from Skylab, light of the sun itself. Skylab scientists created the equivalent of thousands of brief Earth observations of a solar eclipse to study the sun's corona. Before, it was assumed this outer atmosphere was fairly stable. The changes occurred only slowly over long periods of time. But Skylab revealed a much more dynamic corona, with many more changes occurring at faster rates than was thought possible, including this huge bubble, threaded by a magnetic field and extending into the outer atmosphere, rapidly growing to almost the size of the sun itself. Another telescope scanned selected portions of the sun, recording extreme ultraviolet light from several layers of its atmosphere. These layers, lying above the visible surface of the sun, the chromosphere-corona transition zone, and the corona, were scanned simultaneously and are displayed here using various computer-generated colors. In this sequence of ultraviolet photographs, a surge is shot out of the chromosphere and into the corona. By means of such time sequences, the flow of energy upward into the corona can be measured and balanced against the downward flow, allowing for the first time an accurate assessment of the dynamics of the solar atmosphere. For the first time, Skylab astronauts were able to take detailed data of the whole sun in the ultraviolet region of the spectrum. This picture shows the areas of the sun's atmosphere which are between 50,000 and 100,000 degrees Kelvin, at the time of an eruption that lifted this twisted sheet of flame off its surface. The eruption is one of the largest ever recorded, and had grown to 40 times the size of the Earth when the photograph was taken. The X-ray telescopes were designed to study the evolution of the hot, tenuous atmosphere of the sun. Here is an example of a rapid change in structure. This picture was taken at the time when the major reconfiguration took place. At this time, the brightest area was the biggest emitter of X-rays. Its temperature was in excess of 4 million degrees, and perhaps 10 million degrees or more. Skylab studies of coronal holes, dark areas on the sun, show that they may be the source of the solar wind which extends beyond the planet Jupiter. Coronal holes may also have strong magnetic boundaries. As the sun rotates, these huge magnetic sectors sweep by the Earth, disturbing the upper atmosphere. There are indications that these disturbances correlate with the formation of low-pressure weather centers. Addition of solar astronomy has shown us a sun that is far more active, even violent, than we thought. In the next few years, Skylab solar astronomy will tell us even more about the sun, but also about our planet Earth, a cool island within the outermost layer of the sun. Skylab solar studies show our spaceship Earth in its orbit around the center of the sun, interacting with the solar wind, creating a wake extending beyond the orbit of the moon. Earth, man, and all life on Earth in solar forces and events